Okay, so I just want to walk you through the process of thinking through a problem, and I'm just going to do question 3 for chapter 8 as we listen here, and you could just hear me think through a problem out loud. So we read the question, and it's about environmental equity. It's an interesting, somewhat controversial area of research, and the theory they're testing here is does X, the percentage of black people you have in your area, predict the amount of environmental hazards you'll have. And so what they've got is the cases are census blocks. And they're just going to be numbered 1, 2, 3, and I'm going to give it these 3 numbers and just carry that down through number 10. And the question hasn't told me to do this, but I think it's just always good to get the data under your hands in any way possible. So X is going to be the percentage of residents that are black, and didn't like that, and it's just complicated enough so that I can't do this by. Well, let's see if the computer can figure this out. Can it see that? No, it doesn't see that at all. Okay, good. Well, it made a good guess, but it wasn't as good a guess as we needed. So we'll do all this by hand. And I don't know why I was trying to do that with my left hand. If you have a number pad, that's a lot easier. Okay, and now distance in miles. Which is going to be the Y. And I'm going to try to do this with my right hand on the number pad. Should be a lot easier. 1, 3, 1, 2, 8, 6, and 4. And that all looks correct. So now I'm going to ask, go down here and see, read the hypothesis. The hypothesis is that in comparison of census blocks, those with the higher percentage of blacks will be closer to hazards than will blocks having lower percentages of blacks. So, question A, what is the regression equation for this relationship? And interpret the regression coefficient. What is the effect of X on Y? Well, it's asking us what is the regression equation? That is, how do you take this verbal theory and put it into algebra? And we're trying to predict Y, that is how far you are from a toxic waste dump, and we're trying to predict that using the percentage of black people you have in your census block. And so it's going to be something distance from toxic waste equals A plus some B, which is what we're going to find out, times the percent black in your census census block. And I'm gonna merge these cells. How do you do merges in this? Well, let's find out. Merge merge cells. There we go. I guess it just did it. Okay, well. Oh, there it is. That's the merge cell button. Okay, well, now we all know that. Okay. And you might want to put include that there could be some error in there, but we don't have to worry about this just now. Now, interpret the y-intercept. What does the intercept tell you exactly? B. Okay. I'm going to put this in a text box so I can move it around some. What is the y-intercept? The y-intercept is the predicted distance from a toxic waste site. When the percentage of blacks in a census is 0. Okay, and I think that can be for a census district is 0. Okay, and that is just abstractly what the y. Now C. Based on this equation, what is the predicted value of y for a census block? For census blocks that are 15% black, census blocks that are 25% black. Now this is, notice, if you look at this data, you don't even have to do the math. There's two census blocks. There's 0, so the average distance is 27 and 23. And at 10%, you increase the percentage black by 10%, and the average distance is 20. Now, notice here, 27 and 23, the midpoint there is 25, and 22 and 18, the midpoint there is 20. So you see there's sort of an obvious pattern, right? In fact, if we graphed these, it would be pretty obvious. He's concocted this data to fall into a very obvious pattern that is, on average, when you increase this column by 10%, on average, this column, the data in this column is going down by 5 miles in this case. So on average, you go down by 5 miles every time you increase this by 10. And so what is that saying? Well, go back up here. If you look at this, if X is the percentage black, if we increase the percentage black by 1, this will go down by 0.5. So the regression coefficient should be 0.5. Now, and notice in this case, the intercept is 0. That is the place where the intercept is 25. So, going back to this, if we want to put specific values in here, we would say y equals, well, we already know what the intercept is, right? So it's 25 minus, because the effect is negative, 0.5 times percent black. And I'm going to merge these cells so that I don't. What happened here? No. You know what? I still don't know how to merge cells. Oh wow! The help in this thing is so damn cool, and it just does it too. Man, all these years I have been in Microsoft hell for nothing. Okay. So C, based on this equation, what is the predicted value of Y for census blocks that are 15% black? Well, that's not too hard now, right? If you think about it. 15% black and then for 25% black. Well, we can actually just plug this into our equation, right? So, in fact, we can do this. Let's do this to make things clear. Why don't we have it written out up here, what we're going to be saying, right? So, let's take that, make a copy of that, put it here, but let's modify it and say, let's say 15, okay, and then let's do that calculation, okay, and that actually equals then 25 minus times 15. Okay, is anything going to go wrong there? I don't see how it could. 17.5. Well, that makes sense, right? I mean, you can eyeball that, right? At 10, we had 20, an average of 20 miles away. At 20, we had an average of 15 miles away. So if we go half that distance from 10 to 15 on the percentage black, we should go half the distance between 20 and 15, which is 17.5. And let's do this again for what we in the second part of the question. Come back here. Get rid of percent black and put in 25. And then I'm going to actually do the calculations using the spreadsheet minus 0.5 times, this time 25, and get 12.5, which should be no surprise. And we might want to give a slightly more elaborated answer here. I just got rid of that. Okay. Based on these data, a linear regression model would predict that a census block with 15% black residents would have a linear regression model, census blocks with 15% black would, on average, be 17.5 miles from the nearest toxic waste site. Census box with 25% African American populations would have on average 12 point would be on average 12.5 miles nearest waste site. And let me see if I can make that look a little bit. Okay. That's C. And then D, the adjusted R-square. Interpreting an R-square. Oh, and I'm going to do this so it looks cool. How do you do this? I want to so that is caret command plus something to remember to get your superscript R square. That 93% of the in the distance from a toxic waste site can be the variation distance of census districts from toxic waste sites and by African American in those census districts. Those are very short answers, and that took me, well, it didn't take me too long. And there's a lot of little things you could do to sort of improve the aesthetics of this. And we could elaborate a great deal on all this, but this is basically the answer and the approach we would take to question 3 in Chapter 8. And I think I'll just stop recording there.